In this video, we're going to look at using the OpenAI functions, but not for actually triggering a function, more as a way to get JSON out of the large language model. So this is something that has now been added to LangChain. Originally, you could do it playing around and doing it with the actual API itself, but now it actually is built in to LangChain. And they've basically split it currently into two parts, what they're calling tagging and extraction. So I'm going to say that you should think of tagging as more sort of classification. If we're thinking more old school machine learning, that this is basically going to take whatever you've got in there and do a classification. It can be a multi-class classification, and it can be a variety of different kinds of classification that we've got in here. So you can see, okay, we're going to basically have this tagging chain. So we're going to create a tagging chain, and we've got two of them here. We've got just a plain one, and we've got one using a Pydantic class as well. So you can see here, we're bringing in the latest GPT 3.5 Turbo model from the 13th of June. And first off, we basically set up a schema of how do we want to classify, what classifications do we want to do in this. So here we're going to basically do sentiment, and we're going to give it stars, and we're going to go for language. So we're actually getting it to do 3 classifications each time that it looks at it. So it's going to, hopefully say, is it positive sentiment? Is it negative sentiment? Give us a rating for it with the stars, and then tell us what language it's actually in here. So we set up the chain by just passing in this schema into this create tagging chain, and we pass in our LLM. There, we've got the temperature set to 0 there. And then just have a look at what's actually going on under the hood here. You can see that we've got a prompt template in here, and we actually print this out. We can see that it's a chat model, so it's going to be in messages for this. It actually turns out that this is a human template that's going into the first one here. And we can see that it's basically going to have extract the desired information from the following passage. And it's going to give us this passage. But then it's also going to pass in a functions role. So remember, this is going to be the human role up here. But here we've also got a functions role. And we can see that by looking at the LLM quags here. And we can see this is going to be functions. And then this is where our schema information is being used. So we defined this up here. It didn't go into the prompt template like normal. It's actually going into the functions area of this. So you can see this basically matches what we had up above there, that we're going to have sentiment, we're going to have stars, we're going to have language there. And then sure enough, because this is coming out as a string, we need to get it back to the JSON part. So the chain actually uses a JSON output functions parser here, and that's being handled all for us. We don't need to set anything on this. So I've taken a number of reviews from this book called Spare, which seems to be pretty divisive in how it's split up, although most people seem to like the book. And I've basically just pasted them in here. And I've deliberately gone for one that was a 5-star review on Amazon, one that was middle of the road, 3-star, and one that was a -1. So you can see when we pass the first one in and we pass this review in, sure enough, it comes back and says the sentiment is positive, and the stars, it gives 4 for this. It hasn't given us anything about the language in there. So we got, 2 of the classifications done, but we didn't get the third one. Next one we're passing in is the sort of negative review. And sure enough, it says the sentiment is negative here, but it doesn't give us the stars and it doesn't give us the language here. Finally, the sort of mixed one, I pass this in, and you see that what we get back is nothing. So that's not ideal. So my guess is this could be an issue with the formatting, but we're not constraining it enough. That's the sort of key takeaway here. So what we can do is we can set the schema up a little bit more, where we can basically define them as what they're going to be, and then what the possible values for these are. So you'll see that sentiment has a possible value of positive, neutral, or negative now. Stars is going to be 1 to 5. We've got a description of what it actually is now. And then language, before we were just saying language, and we were kind of hoping that the model would guess that we were talking about the type of language. Is it English? Is it Spanish? Is it French, etc.? But now we've actually got an enum in here, and we're passing this in so that we're actually basically saying, right, it's going to be Spanish, English, French, German. And we're also telling it in the schema that these are required things. So remember that this model is trying to predict a function and then the inputs to this function. So it's now being constrained to the, oh, your inputs could only be one of these things. And so now when we run it on the first one, so we basically just redefine the chain again, run it on the first one. Sure enough, now we get sentiment, positive, 4 stars, English. Okay, now it got this wrong, right? This was actually 5 stars, but it's decided that it's only 4 stars in here. Next one up was the negative one. So we run this through and sure enough, we get negative, 1 star, English. Exactly right for what this one was. And then the middle of the road one, we take this and we basically run it through and sure enough, we get neutral, 3 stars, English. Again, fully correct there. And if we look at the output that we're getting, we're actually just getting a Python dictionary here. So if we wanted to make this sort of like a class that we could then pass around easily, we could instantiate an object from a class and pass that around. We basically want to make the schema to be a Pydantic class. And that's what we've got here. So we've got the exact same things as above, but now we've got it as a Pydantic class. And you can see that the chain that we're using this time is different as well. We've now got create tagging chain Pydantic. And then we're passing in this class of tags that we've created here. And now it's going to make it so that it conforms to that. So if we want to actually conform it to being a specific type of object that we can pass around, we can use the Pydantic class that we've got here. So you can see that here we've got the Pydantic class, and we're basically going to create a class called tags. And this is going to have sentiment, stars, and language, just like we had before. But now it's got an enum for each of these, again, like we had before. But now the output is actually going to be a class of tags here. So it's going to be a specific object. So you can see that when we run this thing through now, and we basically just pass it into the create tagging chain here, we pass in the tags in there in our LLM. We pass in the first review that we had. We get the same as we had before when it was structured, but now we've actually got an object of class tags. So now I can just take the response and just say, okay, response.sentiment, response.stars, response.english. And I can basically pass that object around and I could serialize it. I could do a bunch of things that I want to with it. So this can be useful for a lot of different things. So that was the basic classification at the level of the whole input that we had there. The next one that we're looking at is the idea of extraction. So this extraction, you can think about, you've probably heard of NER, like named entity recognition, is where we're going to be using it to go through and get people's names or get particular things out. So here we've got the similar kind of thing. I'm passing in this time a TechCrunch article. So this is a recent article from TechCrunch all about the controversy that's going on at Reddit with the CEO. We can see the CEO's name there. We can see some things, some information about apps, about the actual site. There's a bunch of things in there. There's another person's name in there. We can see some names of apps that are in there as well as we go through this. So this time we're going to be using the create extraction chain. We're going to start off just doing it with the schema like this. So we can start off with just the basic schema. And I'm going to go for a lot of different things. Now, this is probably a little bit overkill here, but I'm going to go for a person's name, a startup, a news outlet, an app name, and then a month. But the ones that are going to be required are going to be the person name and the startup. So I create the chain just like before. If we look in here and look at the prompt, we can see actually what's going on in here. If you just wanted to check what this is, you'll see that this is a human message prompt template in here. So we don't have a system template going in. We're just putting in the human one, and then we're going to have the functions role going in here as well. So we've got this. If we print this out, we can see that it's going to be extract and save the relevant entities mentioned in the following passage together with their properties. Now, one thing I want to stress here is that this is all zero shot. We haven't passed in any examples of startup names or people's names or news outlets or even any of that stuff. If we wanted to improve this, we can actually pass in some in-context learning and pass those things into the prompt as well. But for now, we're not doing that. For now, we're just relying purely on the functions picking it out. So when we look at the functions role, so remember this is going to get passed in as the functions role, we can see that its name is going to be information extraction is the name of the function. And so it's going to select information extraction, and it's giving the description of this extracts the relevant information from the passage. And then what is that relevant information that it's going to pass in? It's actually going to do the function call probably multiple times for this because we've got so much text going through there. So you can see here we've got person name, startup, news outlet. I didn't even have descriptions in these. So you could actually improve this by putting some descriptions into the schema as well. If we go and look at the parser, again, we've got the JSON key output functions parser, and we can basically run this on this, and we'll see now we're getting out a list of JSON objects, and each one is filling out information. So we've got, Steve Huffman has picked up that name, the startup read it, the news outlet. And so what I've done here is basically just put together a little function that's going to go through that output and give us a list of all the things. So when we run this through, you can see here we're going to get people, and the names that it thinks that were in the article are Steve Huffman, Christian Selig, and Reddit. Now, clearly Reddit is not a human, so it's gotten that one wrong. Startups, it's got Reddit and Apollo. I guess you could think of this as being a startup or an app. It's probably more of an app, but it's got some of those there. And then news outlets, and it's kind of got one, but it hasn't done a great job. Months, it's got both of them in there. The challenge here is that you'll find that when you're asking for lots of information out, you'll probably want to limit the amount of information that you're getting it to do it in a shot. So rather than do the whole article in one shot, I've basically just brought it down to like 2 paragraphs here, and we run this. And so now you'll see that when we run it through, there was only one person's name in this because Christian Selig was later on in the article. But you'll see now when we go through, we've got the news outlets where it's picking up all 3. So the news outlets were The Verge, NBC News, and NPR. It didn't get them in above, but now with this one, it is getting them going through. It's got startups being Reddit. It's got apps being Apollo. Doesn't mention the other ones yet. I think it's got only 1 month because April hasn't been mentioned in these 2 paragraphs here. So play around with it. You often find that going for 2 paragraphs, a paragraph at a time, can improve this. Or if you're not going for as many pieces of information, you can go for a longer context for this. Or again, the way that you can improve this is to put some in-context learning examples into the actual prompt itself. That will help you to get better outputs from this as you go through. As always, this one, you could also add in the Pydantic example. It's not going to be hugely different. I'll let you do that when you're by yourself and try it out. But now you've got 2 new ways to extract information out and classify information that you're putting in into whatever it is that you want. So the classification can be very useful for things like sentiment analysis. And you'll notice that as we put in here, you don't have to have it to be just positive, neutral, negative. You could have extremely positive, positive, neutral, negative, extremely negative, something like that. The point is you can play around with this yourself. You could have them being a classification not just for sentiment, but related to a product. So if someone's complaining about a product, you could have the first classification be, what kind of inquiry is it? Is it an inquiry to find out information? Is it sales that the person wants to buy? Is it a complaint? You could do all of these things and then pass them off to different chains that would do something else with this. So that's something that you can certainly do with this. With the extraction, you are not limited to the traditional entity extraction kind of tasks, where generally with a NER model or something, we will want to train it up on a lot of names. We want to train it up on whatever we're going to be running it across to get the right quality output. You can actually put in and get things like news outlet and startup name. And you'll find that the GPT models are actually quite good at being able to work out what those things are, especially if you put it in a description. To make this a lot better, I would first off start by putting descriptions in here of what each of these things are, and then the model will be able to get better at extracting these things out. So this allows you to basically build a lot of cool apps where you can extract information out from a user input or from an article and then turn it from unstructured data into structured data. You can then store it in something like a knowledge graph. You can then use it with the end user again. You can use it as input to another chain as you're going on. Overall, I just wanted to basically point out that this is a really interesting use of the OpenAI functions that we've got here. And we can basically use these now for a variety of different tasks, not just calling a function. We can use them for getting structured output of text that we put in there, etc. Anyway, as always, if you've got any questions, please put them in the comments below. If you liked the video, please click like and subscribe. I will talk to you in the next video. Bye for now.